Good morning, all of you. Today we are going to discuss about what is the basic difference between thermodynamics and heat transfer. See the thermodynamics name. Therm means heat and dynamics means transfer. So thermodynamics means heat transfer? No, not exactly. Even though they are looking same, but their meaning will be different. Generally, thermodynamics now is study of heat, work, and energy transfers in a system. So thermodynamic will be mainly deals with energy conversions, deals with heat and work, deals with the initial and final states of the system. Generally, it will be in equilibrium states. So thermodynamic deals with the laws of thermodynamics. So examples will be heating water in a boiler. So here we are supplying heat to the boiler so that water will be converted into steam. So what is the amount of heat required to convert water into steam? We can able to estimate. From that, steam will be produced. That steam utilized for converting into mechanical work. So we can able to estimate heat converted into mechanical work from the heating water in a boiler. Similarly, engine converting fuel energy into mechanical work. See, here we are using petrol or diesel in engines. So here fuel will be burned, you will get the heat energy. So that heat energy will be converted into mechanical work. So what is the amount of heat we can able to convert from this heat into work? We can able to estimate. Similarly, refrigerator removes heat from inside. So here we are supplying electricity. So we are getting from electricity we are getting mechanical work. So we are converting mechanical work into heat energy. So what is the percentage of conversions we can able to calculate? So based on the thermodynamic principles, we can able to estimate the performance of the various thermal systems. So here thermodynamics now tells how much heat is transferred and does not tell how fast heat will be moving. So here equilibrium energy balance is very important. That is equilibrium conditions are very important. For example, if you take heating of water from 25 to 100 degrees centigrade, so thermodynamic will be calculated total heat required to rise the temperature from 25 to 100 degrees centigrade. So from one equilibrium state to other equilibrium state, what is the amount of heat required to rise the temperature from 25 degrees centigrade to 100 degrees centigrade. So the basic governing laws will be laws of thermodynamics. Coming to the heat transfer, let us understand heat transfer. So heat transfer is defined as the energy in transit. Heat transfer is defined as energy in transit. So due to temperature difference between two bodies. So here the main primary requirement will be temperature difference. Requirement will be temperature difference, and there due to temperature difference, energy will be transit or heat will be in transit or heat will be moving from high temperature to low temperature. So whenever you get the thermal equilibrium, the heat flow will be stops. Example will be hard copy cooling in air, heat flowing to the metal rod. Suppose one rod you take example, you heat at one side and cool at other side. No, the heat will be transferred from hot end to the cold end by means of conduction mechanism. So finally equilibrium conditions will be attained. So engine cooling system also one of the example for heat transfer. So here heat transfer will be mainly focused on heat transfer rate with respect to time, how the heat will be flowing. Studies to temperature distribution. That means with the help of heat transfer principles, we can able to estimate what is the temperature at different locations. That is called as temperature distribution. Heat transfer will be mainly deals with conduction, convection, radiation. These are the basic modes of heat transfer. So example, heating water in a vessel. So with the help of heat transfer principles now, we will able to find what is the time required to get this certain amount of temperature. No, we can able to find the time. So here the basic modes will be conduction, convection, radiation will be there, and accordingly each will be governed by different equations. For example, conduction, no, you will get the Fourier equation. Convection, Newton's law of cooling will be there. Radiation, Stefan Boltzmann and formulas will be there to calculate the different heat transfer rates. So thermodynamics tells from one state to other state, heat will be transferred from one state to other state. So what is the amount of heat transferred we will to find. Here it will be focused on mainly on equilibrium state and does not care about how long the change will be takes place. That means the time factor is not very much important in case of thermodynamics. So it will be focused on equilibrium states only. Heat transfer, whereas heat transfer no, tells you how fast that energy will be moving. It focuses on rate of exchange of heat or specific mechanism like conduction, convection, radiation that moves heat across the temperature difference. It is also estimate the temperature distribution within the body at different locations also we can able to find. Let us see this table, you can understand what is the basic difference between thermodynamics and heat transfer. So heat thermodynamics now it will be definition will be study of energy, heat and work transfers in a system or between the systems and surroundings or between two systems also it will be there. Heat transfer is study of rate of heat flow between the bodies. One body will be maintained at a high temperature, the other body will be maintained at low temperature. Heat is always flows from high temperature to low temperature. That is the definition we have seen already. So here the focus will be equilibrium states, initial equilibrium state and final equilibrium state for thermodynamics. Whereas heat transfer, no, the main focus will be heat transfer rate and temperature distribution. Coming to the time factor now, so thermodynamics we don't have any time considerations. Now here heat transfer you can able to estimate time. Temperature distribution now. So here thermodynamics there will not be any temperature distribution considerations. Whereas in heat transfer now you can able to find what is the temperature distribution at different locations now you can able to estimate. So here the main aspects of thermodynamics will be, main question will be how much heat is transferred from one equilibrium state to other equilibrium state we can calculate. Whereas in case of heat transfer, no, what is the heat transfer rate which is happening in case of no, we can able to find in the heat transfer process. So equilibrium state, no, thermodynamics deals with the equilibrium states, whereas heat transfer will be deals with the non-equilibrium states. So governing laws will be in thermodynamics, laws of thermodynamics will be there, whereas heat transfer, different modes of heat transfer will be there. Each mode you will get one governing equation, like Fourier law will be for conduction, Newton's law for convection, Stefan-Boltzmann law for radiation, like that you will get the basic governing equations. Now example for thermodynamics now, if you consider gas in a piston now, that is one system means if we add heat means the system will be initial state to final state will be it will be reaching. So during that process now we will able to find what is the amount of heat transferred and what is the amount of work done on the system. All those things will be we can able to find. Whereas now in case of heat flow through the wall now we are able to find now a wall is maintained at different temperatures. That means one surface is maintained at high temperature, suppose the other surface is maintained at low temperature. Heat will be flowing due to temperature difference. No? We will able to find heat transfer rate and temperature distribution in the wall. So this is the basic difference between heat transfer and thermodynamics. Okay, let us see a summary. Thermodynamics deals with the quantity of heat transferred between the systems. Quantity of heat transferred between the systems, whereas heat transfer deals with the rate heat transfer and temperature distribution. So whereas thermodynamics, how much heat is transferred is the main concern. Heat transfer, how fast heat is transferred is the main concern. So thermodynamics is state oriented. That means the system will be there. No, it will be state oriented, like initial state and final state will be there. While heat transfer is time oriented. For example, you take the analogy, kitchen analogy. So how we can apply thermodynamics and heat transfer for the kitchen? No? For example, tell us how much electricity or gas is needed to bake a cake. So heat transfer will tell us how much electricity or gas is needed to bake a cake. If you are manufacturing a cake, so this thermodynamic will tell us what is the amount of electricity requirement and what is the gas requirement so that we can make cake. Whereas heat transfer now tell us how long it will take to make a cake in the oven. That is the main difference between thermodynamics and heat transfer. So briefly, thermodynamic deals with the energy transformations, energy conversions in heat into work and other forms, whereas heat transfer deals with the heat flow and temperature distributions, heat transfer rate and temperature distributions. In thermodynamics there is no time factor, whereas heat transfer will be time factor is very important. Thermodynamics will tell us about how much heat is converted to work, how much is heat transferred, all those things will be available. Whereas heat transfer, how fast heat will be, how heat is distributed and what is the temperature distribution in the body also we can able to estimate. Thermodynamic mainly focus on thermodynamics will be works on equilibrium conditions, whereas heat transfer will be a non-equilibrium study will be called. So I hope you understand what is the basic difference between thermodynamics and heat transfer. Thank you for watching. Have a nice day. Thank you.